Okay, so here we go. Today's date, 4, come on pen, 4/12/18. And what we're going to talk about today are going to be square root, graphs, and cubic graphs. Actually, let's make sure this cube root, not cubic, but cube root graphs. There we go, not cubic. Okay. And these are functions. So what I did is I tried to go back and do something very familiar that we've done already, and that'll help us with when we take a look at the back side. So the back side is all the square root stuff and all the cube root stuff. But I thought, let's just start with what we know, and we'll go from there. Okay, so right off the bat, parent function x squared, we know that the vertex is at 0, 0. You guys agree? We know it's 0, 0. And we did that all over 1. 1 squared is 1, right? You go over 2, and 2 squared is 4, right? You go over 3, and we know 3 squared is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We know it's symmetrical because negatives squared are positive, right? So we know negative 1 squared is a positive 1. We know negative 2 squared is a positive 4. And we know negative 3 squared is a positive 9, right? And we get a parabola. We've done this before, right? We've done this before, right? So my vertex is at 0, 0 because it's right there. That's the very bottom point of the minimum. We know the domain is forever wide. Even though it's going up, it's always moving over, right? Even though it's going up, it's always moving over in both directions. So the domain is all real numbers, right? So the domain is going to be x equals all real numbers, right? But the range, reach for your range, starts at a height of 0 and goes up, right? So my range has to be y is greater than or equal to 0, okay? So this is stuff we've done before. It's just a review, okay? So let's take a look at number 2, okay? Amber, will you close your computer for me, please? Thank you. How am I doing? Thumbs up? You ready for 2? So, all right, I know. Ready? I'm going to do the dance, right? Do the dance. Which way am I going?
That way.
Right. So it looks like I'm going left, but really going right. So anything on the inside is a horizontal movement, but it's the opposite, right? So our vertex, we know that's the opposite. So I'm going to have my vertex at positive 3, 2, right? So I'm going to go to positive 3, 2. There's my vertex. And it is the exact same function. So all we're going to do is take what we had up here, and we're going to move my vertex to the point 3, 2. So we've just translated, it's called a translation. We translated our parabola, so it's going to be the same 1, 1, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And of course, you know, there's a line of symmetry because it's a parabola. It is symmetrical over its vertex. So we're going to have a reflection there, a reflection there, and a reflection. Okay, so there's our parabola. Hopefully this seems really easy because we've done this, haven't we? Right? So this is just a review, just going back through the review. So when we flip the page, we're going to be looking at its inverse, okay? All right, domain range. Well, domain obviously is forever wide because even though it's going up, it's still always moving over, isn't it? Always moving over as we go up. So my domain has got to be x equals, again, all real numbers. But my range starts at a height of 2, and goes up, right? So we're going to say, okay, y is greater than or equal to 2, okay? Thumbs up? Okay. Okay, all right. 3, the only difference that we have to be careful of is there's a negative right here, okay? So because it's a negative, it's just going to be a reflection over the x-axis, or we'll just say it's upside down. How's that? Probably easier. Let's use real words that you guys know. It's just basically upside down. Okay. A math word is it's a reflection over the x-axis. How's that for a mathematical word, huh? So we know the vertex is going to be negative 1, 4, right? Opposite, right? Opposite. So we'll go to negative 1, 4. And it's the same parabola except for it's upside down. We're still going to do our 1, 1, our 2, 4, our 3, 9, but it's upside down, right? Go 1, 1, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course we have our line of symmetry which goes through the vertex. So we know we have a reflection here, here, and here. Okay. Domain, all real numbers, right? Domain is all real numbers. X equals all real numbers, and the range is y is less than, because it's going down, less than or equal to, less than or equal to, starts at a height of 4 and goes down less than 4, okay? So that's review. What we want to do now is flip the page and look at it, the square root graphs. Now, square root graphs are the same type of thing, okay? So the square root graphs, you ready? The square root graphs are going to look like this. Square root graphs are going to look like this. They can't have the bottom part for two reasons. One, it wouldn't be a function, right? Remember we talked about functions? Wouldn't be a function, right? And these are the negatives, and you can't have negative square roots, right? You will close. Renee, do you mind closing the door? Or Katie, thank you. So let's turn the page, see what we get, okay? Yeah. Yeah, make it real quick. Okay. So number 4, we're going to do the square root. So you ready? We're still going to do our 1, 1, 2, 4, 3, 9, but we're going to do it just the opposite because we're going to take a look at square roots. I got to take square roots of certain numbers, right? So the numbers I like is let x equal 0, 1, 4, and 9. Those are the numbers I like because those are perfect squares. We could use any number, but then we'd have to use a calculator, and we get decimal answers, okay? We already kind of know what the shape is, so we'll just start with square root of 0 is 0, right? So if we go over 1, the square root of 1 is 1. I don't know, on my desk maybe? Yeah. Square root of 4, 1, 2, 3, 4. Square root of 4 is 2. See how I'm doing this? Then we're going to go to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. And of course the square root of 16 is 4, but I'm going to run off my paper, okay? So it's still the 1, 2, 4, and 3, 9, but it's just the backwards, the opposite, so I get a graph that looks like this. Now, with square root graphs, we can't use negatives, right? So there's no values back here, because you can't put in negatives, right? And there are no values down here because there's only one answer, right? So this is my graph. That is the parent function. This is my parent function.
But the square root of 4 could be negative 2.
If I put it as an equation, y equals x squared, yes. Well, yes. But that's not the equation, is it?
Y equals the square root of x.
Right? So it's different, isn't it? Right? I agree with you. But we only get one answer because it's not that, it's this question. It's different. Does that make sense, Claire?
Sure.
And there's no plus or minus out here, is there? Right? And not only that, Claire, it wouldn't be a function, would it?
Yeah.
It wouldn't be a function, right? It can't be a function, right? So, and that's why we'd need, and I'll show you on the calculator where you'd need two equations to get it, but it's not a function.
Yeah.
Okay, let me graph. Let me show you something real quick, Claire. You asked a really good question, okay? You guys mind if I take a Claire question real quick? So, Claire, when I go to my calculator and I go to y equals, Claire, let me go ahead and get a better window. So let me go from, say, -1 to, say, 10. -1 to 5, okay? Now if I go y equals, right? Let's go the square root of x, okay? Graph it. Right? And that's what I just got, right? If I want the bottom half, it's not a function, which would take two equations to get the bottom half.
Yeah.
So if I went y equals and made it a negative square root of x, I could, but then that's okay because it's one function and then a second function. And I could get it, but I'm not going to do that, right? And that will get you the bottom half. Here, let me change my window real quickly. Let's make this a -5 graph. There's the top one, there's the bottom one, but it's two separate graphs.
Yeah.
Okay, good.
It can't be a function, that's why they do it like that. Yeah.
Exactly. Okay. Now, how about number 5? So number 5 is the exact same graph, right? So it doesn't have a vertex, but let's call it an endpoint, okay? Okay, it doesn't have a vertex, but it has an endpoint. So the endpoint is opposite, which is 3, 2, right? It's got to be the opposite. So let's go to 3, 2. And this really is a translation, so we're going to take our original parent function and draw it down here. Except we'll start at this endpoint. It's the exact same graph, it's just been moved to here. Exact same graph, it's just been moved to here. So we'll still do our 0, 1, 4, 9, because if we go over 1, the square root of 1 is 1. We go over 1, 2, 3, 4. Go over 4 because the square root of 4 is 2. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, and the square root of 9 is 3. And there is my function. Okay? Alright, domain x is greater than or equal to 3. Okay? Starts at 3, starts the next value 3 and moves over. See that? The range is going to be y is greater than or equal to height of 2, and it goes up, doesn't it? Okay? Y is greater than or equal to 2. There's my domain and range. Okay? Oh, domain and range here would be x is greater than or equal to 0 and y is greater than or equal to 0. I should have put that up there. But then I went to a clear question, so, you know. You guys agree with that one on that domain and range? Now, a cube root. Let's put the cube root up here, okay? I want these numbers. I want 0, 1, 8, 27. And I also want to try -1, -8, and -27, okay? You can have negative numbers for a cube root. You can, because what's -2 times -2 times -2? It's a -8. Okay, with me? Listen, -2 times -2 times -2. -8. Okay, -2 times -2 times -2 is -8. So the cube root of -8 is okay. It's just -2. What this means is to do a cube root graph, we can have negative values. We can. We can do any negative value we want. So let's go. Okay, if I plug in 0, we're going to just do the parent function. Cube root of 0 is 0, right? Okay. If I go over 1, cube root of 1 is 1. Now I'm going to go all the way to 8 because the cube root of all the rest of these numbers does exist. It does, but we'd have to get a calculator answer. I mean, we could say, okay, what's the cube root? I could go, math, cube root 3, but I mean, I could, but then I get some decimals, right? So why not just go for the easy numbers, right? So for me, the cube root of 8, 1, 2, 3, 4, 5, 6, 7, 8 is 3, right? Now I'm not really going to do 27 because it's going to be off my paper. I could, but 27 is going to be way out there, right? So bag it. I got a general idea. Cube root of -1. What is the cube root of -1? It is -1, right? So I'm going to go -1. Cube root of -1 is -1. Cube root of -8 is -2. So if I go back 1, 2, 3, 4, 5, 6, 7, 8, the cube root of -8 is -2. So I go -2. Okay. This graph looks like this. Okay. Now you can do it on your calculator. You really can. So if you want to do this on your calculator, you can just simply go to y equals. Okay. I'll clear that. Clear that. Clear that. And I'll do math. I can go to a cube root of x. Let me change my window. Oh, probably -10 to 10. -5 to 5 work. Here it is. Okay. There it is. Looks just like what we just did, doesn't it? And you get this little bump here. That's called an inflection point. Okay, that's called an inflection point, where just this little turn here. Okay, in business, an inflection point is where a business maybe reinvests, builds another building, opens another restaurant, and all of a sudden things start to take off again. That's an inflection point for a business. Okay. No, cube roots can be, right? Square roots can't. Square roots cannot be negative, but cube roots can. You want to show you why? Okay. So, What's the domain? What's my domain? What's my domain? How wide is this graph? All real numbers, right? X equals all real numbers. What's my range? What's my range? Is it always going up? Is it always going down? It's all real numbers. I mean, it is going down. It's just going to take a long time to get there, but it's always going down, right? So the range is y equals all real numbers. Okay? All right, now, let's take this one and graph it over here, okay? Cube root. So first of all, let's call it the endpoint. So my endpoint is going to be at -1, -3. No, let's not call it an endpoint. Let's call it an inflection point. Inflection point. That's what it really is. Inflection point. Let's call it an inflection point. So my inflection point is at -1, -3. Right there. My inflection point's at -1, -3. Okay? And so I'll do the same exact graph. I want to take this original parent function and I want to put it right there. Does that make sense? I want to take this parent function, I want to put it there. So we'll do the same thing. I'll go 1, 1, 8, 2. I'll go -1, -1. I'll go -8, -2 from my inflection point. So I'll go, okay, I'll go 1, 1. I'll go over 1, up 1. I'll go 1, 2, 3, 4, 5, 6, 7, 8 from my inflection point up 2. I'm not going to do 27. That's off my paper. So then I'll go back from my inflection point. If I go back, -1, the cube root of -1 is -1. I go 1, 2, 3, 4, 5, 6, 7, 8. Cube root of -8 is -2, so it's down there. Okay. Okay. Domain and range. Oh, it's always right. Do you agree? No matter what you do, it's always going to be all real numbers for all of these cube root graphs. It has to be. Okay, so now, example 7. We have a negative inside. We haven't done this for a while. It's on the inside. If it's on the outside, right, if you have negative on the outside, think about this. Negative on the outside is a reflection over the x. So negative on the inside, which way do you think we're going to deflect? Over the y, right? Right? Over the y. Does that make sense? So we're going to flip it over the y. We're not going to flip it over the x. Okay, so we're going to do a reflection over the y-axis, but we're really going to reflect at our inflection point. We're going to inflection over the y-axis at the inflection point. Okay, let's see. First of all, let's get our inflection point, okay? So we're going to take this thing and we're going to reflect it over the y, but at the inflection point. So my inflection point's at -3, -2, right? That's my inflection point. Call that an IP. How's that? IP inflection point. So let's go -3, -2, right? Oh, I'm wrong. I'm wrong. +2. Darn me. Claire, you got to help me out here. Katie, come on, Katie. Katie, you got to help me. Yeah. All right, where's my whiteout? Here it is. Thank goodness for whiteout. That's right, you guys. Between all of us, we'll get it right, huh? It's almost Friday. We're getting tired, huh? So
it is almost Friday.
So now we're gonna watch my hand. We're gonna go 1, 1, 8, 2, right? Except we're gonna do it that way. Does that make sense? One more time. I'm going to go 1, 1, 8, 2, except for I'm going to do it that way. I'm going to flip it, right? So I'm going to go 1, 1 like that, because it got reflected. 1, 2, 3, 4, 5, 6, 7, 8, 2. I'll go 1, 1 like this. 1, 2, 3, 4, 5, 6, 7, 8. And here is this particular graph. Okay. So it's my parent function, this one. It's been shifted to this inflection point, and then it's been flipped, right? Or you can flip it first and then move it. Either way. Okay. So domain and range, are basically the same thing. Domain and range have to be all real numbers, right? Okay, so today, not a lot of work. We got lots of time, lots and lots of time. Page 624, 2 to 10 all, 24 to 32, and 86, okay? All right, you guys want to play the game first before you do your homework? Or you want?
No, I want to get my homework.
All right, let's get the homework done. All right. How about tomorrow, Bailey?
Yes.
Okay. Tomorrow for candy, huh, Bailey? It's a fun game, isn't it? And then I got another game like that. Bailey, you want to see the next game?
Yes.
Here, stand up.
Okay.
We'll play these two. Okay, we'll play these, okay? But no cheating allowed.
Oh, that's.
No cheating allowed,
Oh
okay?
God, I'm
You
scared.
gotta stand up. Well, you don't have to stand. You don't actually have to stand.
Oh my
Okay?
God! I just set off.
Let's
Stand
Right? Okay, so. Okay, use both hands.
Okay.
Okay, we'll demonstrate. Okay. Okay. Now you ready? We're gonna go. You guys are on your back. So if I say the number 6, bring out your two hands and give me a 6. Okay, so 1, 2, 3, go. So you didn't get it.
Oh, we
Okay.
have to do the same.
Ah, okay. 1, 2, 3, go. Oh, seriously, we lost a bit. Okay.
What number? It's the same number.
Yeah. We want a
Okay.
6,
It's
right?
like what are the
1,
but
but you can't
no,
do the same throw 2 times in a row. Okay.
Oh, I
So
can't.
1, 2, 3, go.
Wait.
Ah! Wait. If we were playing them, we would have lost a long time ago, right? Okay. Oh my God. Anyway, I call that the finger game.
You suck. I didn't.
I'll explain that one better tomorrow. Okay.
I get it. Wait.
Oh, I'm still recording. Shoot.
Now they know how to play.
Yeah.
I'm still recording.